Hey, we're doing some Python programming, kind of building on what we know, and I think what we're going to be doing here is just using some stuff that we have already learned. Okay, so in this particular one, we're going to be simulating rolling one die, so it's not going to be one. In the next tutorial, it will be two. All right, but in this one, it's just going to be one. And what we're going to be doing here is we're going to simulate, we're going to roll a die, and we're going to call that a trial, and we're going to record what number comes up on top. And so we're going to actually simulate this in a Python program, and then what we're going to do is we're going to count. So we're going to have like let's say 1,000 trials, and then we're going to count how many times sixes come up. All right, and then we'll put the number of sixes over the total number of trials, and what should happen is the number of these trials increase, we should converge towards the theoretical value of asking the question, what's the probability, if we roll a die one time, what's the probability that a 6 comes up, that a 6, now we're just talking about one die here. Alright, so we're going to start off with something simple, and then we'll work up towards a little bit more difficulty of asking or try to answering the question of rolling, let's say, two dice. So let's go ahead and get started on this. All right. Okay, so we're going to be rolling, like I said, one die, and we're going to be selecting at random, right? Well, I say at random. We roll the die. We'll consider that the random number comes up. So we're going to need to do something here. Since we're going to simulate that, we're going to import the random module. Okay, and we'll go ahead and declare a variable. We'll call this one trials, the number of trials, and we're going to start off with just 100 trials, let's say. So that would be like rolling the die 100 times, and after each time we record the number that appears on top. Alright, and we'll need to do some counting here, keeping track of some things, and this particular one here, will be keeping track of the number of trials, and in this variable we'll be keeping track of the number of sixes that come up. Alright, and of course we're going to use the while statement. Alright, and now we'll need to we'll call dn the die number. We'll need to randomly generate the number that comes up on the die, so we'll do that right there. Alright, and let's see, let me think about this for a second. Okay, so we'll need an if statement. Alright, we'll need an if statement. So if the die number is equal to 6, okay, if the die number is equal to 6, then we will count that. Alright, so we'll keep up with that. Now remember, there was two different ways of doing this. I'm not going to repeat this much more. I'm just going to do it. Okay, so we're just going to write it like that. Alright. Okay, so this will count the number of ways the die comes up. Now I'm going to go ahead and just print this off. So we're going to print wait a minute, we don't want to print that. We want to print on the screen every time the die comes up. We want to print what that number is. Alright, so after the if statement, okay, so we'll need to count the number of times this happens. That'll keep up with, so when C reaches, for example, 100, right, when 100 is equal to the number of trials, and then it becomes 101, and then this will be false right here, and then the program will break there. Alright, let's go ahead and print. Let's go ahead and just print off what dn is. Alright, we'll do that. Okay, so I think that's pretty much it. So when C reaches 101, then then it will break. And then what we'll do is we'll print off. Now this notation here, X is this capital X is what's known as the random variable, and that random variable is defined to be, we're looking for a 6 on that. Alright, and basically what this says is what's the probability that X is equal to 6. Alright, so we're going to count, let's see here. So C6 is the number of times that 6 comes up, and then of course over the total number of trials. Right, total number of trials. Okay, now let's think about this theoretically. If we were asked to find what's the probability, roll the die one time, roll the die, right? What's the probability that a 6 appears on top? Well, obviously there's only one 6. And then down here in the bottom of the fraction, there's 6 possibilities. Okay, so there's only one way for this being true, but you can consider this down here true or false. I don't know, maybe that's a little bit arcane there for you, but this is the number of ways that the outcome can happen, which is only one way since there's only one 6 on the die, and then this is the total number of possibilities. Okay, so 1 over 6. Alright, well let's go ahead and run this. See what we got here. Hopefully everything is gonna come out good. Okay, so as you can see here, let's scroll up the screen. Right, so we rolled the die and what came up? A 4, and then we rolled the die again and then a 5, and we rolled the die again and then a 1, and then we rolled the die again and a 5, and then we rolled the die again, and look at here, we got a 6. Right, so this is where the first 6 appears. Okay, and then there's 2, 3, and so forth. Alright. Okay, so let's look at this experimental value here, which can. Oops. So we're running, let's call it an experiment. Now, what is going on here? Okay. I need to get this on the screen. Okay, so this is really not an equal sign. This should be an approximation sign, and I've been kind of looking for that, but I can't find it. Okay, so this should be an approximation sign. In other words, as the number of trials increases, this thing should converge towards 1 over 6. Okay, 1 over 6. And of course, 1 over 6, the theoretical value. Okay, hold on just a second here. Right, so this thing should be converging towards approximately 0.1666666666666 and remaining, right? And it goes on, so 0.167 or something. But that's what this number here should converge over towards the more trials that we go on. So let's actually experiment with this. Do a little experimentation there. So let's add 2 more zeros to that. Okay, and then we'll run the program. So this thing is going to run a whole lot longer if we print off print off the numbers than if we didn't print off the numbers. Okay, so keep that in mind. Then that's probably what I should have done here. I should have just went and actually we'll do that. Let me just stop the program. Okay, so we'll go in here. We'll get rid of that. Now watch how fast it runs now, because it won't have to do that. Wow, what happened there? Not exactly sure. Oh, I quit the program. Yeah. So as you can see, it was almost instant. Now you notice the number right here, it's 0.1677. So it looks to me, now let's run it again actually. Let's run this thing again. Okay, so this time we got 0.1634. So it's the number of zeros here, number of trials that we can all right, we start converging towards the actual theoretical value. Okay, notice this 0.167. Let's do this again. .165. Let's add another 0 here to this. Add another 0. What we're going to do in the next video is we're going to ask a little bit more difficult question, and we'll involve either, you can either think of it as rolling the die twice in a row, or you can think of rolling 2 dice at the same time. It doesn't matter. Okay, so what do we got going on here? So as you can see, this number is going to start converging to 0.16. It's going to get closer and closer and closer as the number of trials increases. We're going to do this one more time, and then we're going to take a break. So as you can see, it's taking longer and longer for us to get the result. And so the more powerful your computer is, the faster this thing is going to appear. Right, I wish I had a supercomputer, that'd be nice. Alright, so it's taking a little bit of time here, and of course this will be the last one, and we're going to end this and move on to 2 die. Okay, so as you can see here, look at here. So this time we've got 0.1666, right? And remember, it's 66666 on out. Okay, so there you go. We are running what's known as a simulation, right? So we wrote an algorithm to simulate a process, and really powerful stuff, because who's going to sit there and roll a die all day long and record the number of times 6's come up? Who's got time for that? Anyway, so we're over here doing some Python programming. Of course, that's me. And if you need any math help, you can go to gotomath.com. This is where we keep all our videos. All right. And I shall see you in the next tutorial.